At the very heart of all this amazing blockchain technology, there's a fundamental challenge. You could almost call it an Achilles heel. It's a weakness so significant it could hamstring the whole thing, but it's also where some of the most brilliant solutions are popping up. Today, we're diving deep into what's known as the Oracle problem. Just take a second and think about the world around you. Seriously, that phone in your hand, your car insurance, your mortgage, pretty much every single part of our modern lives runs on agreements. And at their core, they're all just promises. A mechanic promises they'll fix your car. You promise you'll pay. A bank promises your money is safe. For basically all of human history, we've relied on what you could call brand-based trust, right? We trust a big company because we recognize the logo. But let's be honest, it's really just a glorified pinky swear. And that comes with this massive vulnerability called counterparty risk. That's just a fancy way of saying there's always a chance the other side just won't keep their promise. And the thing is, these promises get broken all the time. The 2008 financial crisis, a catastrophic worldwide failure of trust. Or how about the McDonald's Monopoly scam? That showed how a single insider could totally rig a supposedly fair game. And more recently, remember when Robinhood just stopped trading during that huge stock frenzy? They broke their core promise of giving people fair access to the market. In every single one of these cases, a central party put their own interest first, and it had massive consequences for everyone else. So this begs the question, what if we could engineer promises that actually couldn't be broken? What if we could build agreements that were guaranteed by their very nature to execute exactly as they were written? Well, this is precisely where blockchain and smart contracts come into the picture. So a smart contract is really just an agreement, but instead of being written on paper, it's written in computer code. The absolute best way to think about it is like a digital vending machine. You put in a coin, that's the data or the value, and the machine is hardwired to spit out a soda, that's the outcome. There's no person in the middle deciding if they feel like honoring the deal. The rules are just the rules, period. Now, these digital agreements get their real power from three core properties of the blockchain they run on. First, they are immutable. Once the rules are set, nobody can change them. Second, they're decentralized. There's no big red off switch like Robinhood had. And third, they're transparent. Anyone, and I mean anyone, can go look at the rules and audit them. So here's the big takeaway. You're shifting your trust away from a person or a brand and onto the cold, hard, verifiable logic of the code itself. Okay, so this system sounds perfect, right? Almost utopian. You've got unbreakable, transparent, decentralized promises. But there's a catch, and it is a massive, fundamental limitation that you might not see coming at first glance. And here it is, the critical question. What happens when your perfect little digital vending machine needs to know something that happened outside of its digital world? What if it needs to know the weather in Omaha or the final score of the World Cup? This is what we call the Oracle problem. See, blockchains are designed on purpose to be deterministic systems. They are completely sealed off from any external data. I want you to picture a brilliant judge who's been locked in a soundproofed room. Inside that room, they can enforce the law with perfect fairness and logic, but they have absolutely zero information about what's happening outside. They are completely deaf and blind to reality. And believe me, this isn't some niche, abstract problem. So many of the most valuable agreements we can make depend entirely on real-world data. Think about it. Crop insurance needs weather data. A bet on a sports game needs the final score. Flight insurance needs to know if the plane was actually delayed. A smart contract all by itself can't access a single piece of this information. Okay, so if the blockchain is a soundproof room, how in the world do we get information inside? We need a secure bridge. We need a messenger to connect that room to the outside world. We need an oracle. Now, in this context, an oracle isn't some mystical fortune teller. It's much simpler. It's basically a service that acts as a trusted data messenger. Its job is to go out, find and verify real-world information, and then securely deliver it into that soundproof room so the smart contract can finally act on it. But wait a second, hold on. If we use just one oracle, haven't we just recreated the exact same problem we were trying to solve in the first place? We've just replaced trusting a centralized company with trusting a single centralized data messenger. If that one messenger is corrupt or gets hacked or even just makes an honest mistake, the entire unbreakable promise completely falls apart. We're back to square one. And this is where the solution gets really, really clever. It's called a Decentralized Oracle Network, or a DON. So instead of trusting one single messenger, you have a whole army of them. When a smart contract needs data,
the request goes out to a whole network of independent Oracle nodes. These nodes all go out and fetch the answer from multiple different sources. And then, and this is the key part, they all have to agree on what the correct answer is before a single validated piece of data is delivered to the blockchain. It's genius. It decentralizes the data delivery itself. So let's see how this could actually build a better world. Remember that McDonald's Monopoly scam? With a Dawn, that would have been literally impossible. A specific service called a verifiable random function, or VRF, could run on a Dawn to generate a provably random and tamper-proof winning ticket. The entire process would be transparent and auditable from start to finish. Any kind of insider rigging would be cryptographically impossible. Okay, so we have our unbreakable contracts. And now we have a secure bridge for them to get real-world data. But where does all this stuff actually happen? I mean, what's the environment where all this code actually runs? It's a great question, right? We can't just run this code on some random person's laptop or on Amazon servers, because that would just reintroduce a central point of failure all over again. No, we need a very special kind of computer. And the answer is the Ethereum Virtual Machine, or the EVM. The best way to think of the EVM is as a single global computer that's made up of thousands of individual machines, all running in perfect sync. It's the shared, decentralized environment. It's like the operating system, if you will, where all these smart contracts live and execute their instructions. It's really the foundational layer for this entire new world of verifiable applications. All right, let's put all the pieces together now. We've got the blockchain, we've got smart contracts, we have decentralized oracles, and we have the EVM. What does this new tech stack actually let us build? What's the point of it all? Well, this table really sums it up perfectly. You take a problem like market manipulation, which we saw with Robinhood. The decentralized solution is something like Uniswap, a decentralized exchange running on the EVM that simply has no off switch. Or you take the problem of opaque backroom accounting that led to the FTX collapse. That's solved by transparent DeFi protocols where every single asset is verifiable on-chain. And like we just talked about, a rigged promotion like the Monopoly game gets solved by a smart contract combined with a decentralized Oracle network. So, and this is a really crucial point, massive failures like FTX were not failures of this new technology. Not at all. FTX was an old world, centralized company with secret, opaque books. It's the very model this technology is designed to replace. If anything, these catastrophic failures make the case for transparent, on-chain systems even stronger than it was before. So really, it all comes down to this. We are, right now, in the middle of a massive shift from a world of breakable, brand-based promises to a new one of verifiable, math-based guarantees. For the very first time in history, we have the tools to build systems that are inherently more fair, more transparent, and more resilient. The question is no longer if we can build a more trustworthy world. The real question is what kind of world will we choose to build with it?